Okay, welcome back. Now we're going to do an example of how to use the squeeze theorem. Okay, so now if we look at this and kind of like investigate and think about this, as x is approaching 0, this is a product, right? This is approaching 0. What is cosine of x approaching when x approaches 0? It's approaching 1. Okay? So what this is going to, it's going towards 0 times, or excuse me, 0 times 1, which would tell me that the limit of this thing is probably 0. But let's use the squeeze theorem to determine that that is indeed the case. Now that I would suspect that that's where this is going, but let's use the squeeze theorem to help us. So here's what we know. We know that cosine, the domain or the range of cosine x, right, is always less than or equal to 1 and greater than or equal to -1. Which means that if I multiply everything by x, right, the absolute value of x, then I also get that x cosine x is less than or equal to the absolute value of x and is greater than or equal to the negative of the absolute value of x. Okay? Now, if I take the limit, since this is true on any open interval, this is going to be true on any open interval close to 0, right? So again, this satisfies the conditions for using the squeeze theorem. So now if I take the limit of all three of these, right? So if I take the limit as x approaches 0 of the negative absolute value of x, okay? What is that going to equal? Well, as x approaches 0, that's going to be 0. Well, what about over here? I take the limit as x approaches 0 of the absolute value of x. Well, that also is going to 0. So then by the squeeze theorem, what do we know? It must be true that the limit as x approaches 0 of x cosine x also equals 0. And that's it. So now what we're going to do is we're actually going to go through some important applications, some important examples of using the squeeze theorem in the next few videos. Okay? So stay tuned.